Yeah, that's question number 1. Initially, velocity is displacement over time. And so you can find the time using displacement over velocity. The problem says that the displacement is 130 kilometers, right? And the velocity was 95 kilometer per hour. So if you divide them, you will get the time in hours. And so you get it as 130 divided by 95, which is 1.4 hours. That is the time that you took to drive home from school. That's clear, isn't it? And then it says it began to rain and you slowed to 65 kilometers per hour. So now you have to find the time that you took by subtracting. It's given us 3 hours, 20 minutes. You got to change it into hours, right? How do you do that? 20 divided by 60, so it goes 3.33, and I took note of significant figures, that's why it's 3.3. And so when you're driving at 65 kilometers per hour, you have already driven 1.4, so the remaining time is 1.9. Is that what you got? 1.9 hour? Okay. And then you calculate the displacement during that 1.9 hour just by multiplying, and you get it as 120. So now you add the 120 to the 130, and you get the total displacement, which is 250 kilometers. But in question 2, the average speed, you know that average speed is total distance by total time. And in this case, the total distance is 116, and then it comes back half the way, isn't it? So you got to add. Oh no, this is the B part of problem 1. I'm sorry. Did you notice that problem 1 had 2 parts? I was not even looking at it. So the average speed is total distance by total time, and we got the total distance as 250, didn't we? 250 divided by 3.3, that's 76 kilometers per hour. Okay, that was the B part of problem 1. I was not looking. All right, question 2. I tried to draw. Isn't that what the horse did? 116 meters to that side and back again by 58 meters. So the total distance is 116 plus 58. Correct?
Yes.
That gives you 174 meters, and the time taken was 4.8. So the average speed is that distance, which is 174 divided by 4.8. Gives you 36 meters per second. Are we good on that? 3 now. What's the formula for average velocity? It's displacement by time. And the displacement is only 58 meters. And what's the time taken? I missed. Didn't I miss it again? Yeah, I missed it again. I was not even seeing that. Okay. So what do you get when you divide? That's 18.8. And what do you get? 2.09? 3.09. Thank you. 3.09 meters per second. Okay, so number 3, that's the car and the truck, and the spacing is 110 meters. Don't you laugh at what I draw. And the truck is moving at 75 kilometers per hour. The car is at 88, isn't it? You got to change both into meter per second, or just keep that in kilometer per hour and change the distance into kilometer. Okay? So first what you do is the relative velocity of the car compared to the truck. How much is that? How fast is the car moving compared to the truck? 13. So that's what you do first. So you take 88, take away 75, you get 13 kilometers per hour. And then you know the distance between them is 110 meters. So change it into kilometer. How do you change? Divide by 1,000. So you got it as 0.110 kilometers. And then velocity is displacement over time. So that's the time it takes to catch up. That's 0.11, and then rearrange. So time is displacement over velocity. 0.110 kilometer divided by 13 kilometer per hour. Remember that you're going to get the time in hours, isn't it? Yeah, you're going to get the time in hours. So you got to convert it into seconds, multiplying by 3600. So when you multiply, you get, and check this calculation. The acceleration is given, that's in meter per second squared, while both the velocities are given in kilometer per hour. So what you got to do is change both kilometer per hour into meter per second. That is what I've done. Multiply each one by 5, divide by 18, and you get 22. I'm just rounding off to 22 and 31. And then acceleration is v2 minus v1 by delta t. Plug it into that. Make time the subject is 31 minus 22 by the acceleration, which is 1.6, and you have the answer. All right, 5. V1 is 21, V2 is 0, delta t is 6 seconds. You got to find delta x. That's how you write down for every problem. It's not silly. It's very important that you write it down. Otherwise, you'll miss it. And then use that formula. 21 plus 0 by 2 times 6.00, 126 meters. So that is 63? Okay, that's fine. Just what I told you. Change the 95 kilometer per hour into meter per second. 26, significant figure. That's why 26 meter per second. The final velocity is 0. And I'm saying the displacement in 1 second is 26 times 1. I'm trying to show you. Because displacement is velocity multiplied by time, isn't it? Okay, so you got 26 meter. And then in the A part, it says that the acceleration is how much? How much is it? Negative 4. Negative 4. So you're going to tie that in. What's the initial velocity? 26. What's the final velocity? 0. And you have your acceleration as negative 4. Okay, so that's what I'm writing now. And this is a new equation that we have not used, but you got to remember this. So I'll stop it right there. Rearrange and make displacement the subject. Plug in the numbers. I'm not going to read all the numbers. Then you get negative 676 by negative 8, which is, of course, positive 84.5 meters. That is the distance or displacement after you hit the brakes. And the 26 was before you even hit the brake, right? And so the total displacement, you've got to add both of them. You get 110.5 meters. All right, the B part, I did it, so I just wanted to roll on the B part. Again, the same thing. 2 times negative 8, that's equal to this. You get it as 42. And the total was 26 plus this. 68 meters. What was the answer for the first one? For A? 7. Just for the sake of those who did not do it. I wrote everything down. Delta x is 0. V1 is what you have to find. Delta t is 3. A is negative 9.8. That's the equation. Plug the numbers in. You're looking for V1. Half times negative 9.8 times delta t squared. All right. Algebra, that's it. Half times negative 9.8 times that gives you negative 44.1. And so rearrange and you get 3v1 is that. v1 is 44.1 divided by 3. That is 14.7 meter per second. Hold on. To find the height, delta t is 1.5. V1 or V0 is 14.7. A is negative 9.8 because it's going up. And delta x is what you're looking for. So again, it's the king. Plug the numbers in. Do not make a mistake, and you have the answer. Okay, half times negative 9.8. 1.5 squared. Maybe somebody missed the square. I don't know. I got 11.1 meter. The picture is very clear, isn't it now? Okay. 5.20 going up. V1, that is 5.2. It's not 0, again I'm telling you. A is negative because it's going up first. Delta x is negative 125. You're looking for? I'm trying to show that the positive is up and the negative is down. Okay. That's the equation that you use. And be careful when you plug in the numbers. You know how I got negative 4.9 because that's going to repeat every time. Half times 9.8. So and that's a quadratic equation. Just be careful when you bring it to the other side. It becomes positive, this becomes negative, and this already is negative. So you know that for a quadratic equation, you have the form ax squared plus bx plus c is equal to 0. And I'm trying to show you what a is, what b is, and what c is. Can you see it?
Yes.
Okay. And the formula is minus b plus or minus square root b squared minus 4ac by 2a. Yeah, that was a long story. Anyway, you see that? You have to remember it. You have to. And then put it in. It's negative b, so it becomes positive. Put all the numbers. Be careful with the sign. There are two negatives, so it will become positive. So on and so forth. And I ran out of space there. Are you trying to write as fast as? I mean, you may be able to, but even if you can't finish, don't finish. It's always going to be there for you. Okay. Can I move on, please? All right. So you can get to go at least 5 minutes early. And then you get 5.20 plus or minus this by. And you get. Did I forget the minus? Why didn't I? Oh, yeah, I wrote it that side. Okay. I wrote it as two separate ones. But I put a circle around it. Somebody tell me why. What are we looking for? Time. Can time be negative? No. That's why I don't need this. Because that's going to be a negative. So therefore, you only take one of them. 5.6 seconds. Number 9. This is the initial velocity is 18 meters per second. The acceleration is negative 9.8 because it's going up. You have to find the final velocity. And delta x is 11 meters, so v2 squared minus v1 squared is 2a delta x. That's the best equation to use, isn't it? Okay, plug the numbers in, and you would get 18 squared plus 2 times negative 9.8 times 11. Solve all that, take the square root. That's the answer to A that we are about to get. 108, take the square root of 108, and you get 10.4 meter per second. The B part, again, you got to find time. So time is, and use any of the equations. I just used this. You could have used any easier one. Plug it back in, find the time. And if you do this way, you're going to get a quadratic equation which will give you two answers. And surely you need to have two answers, isn't it? Because once it will cross the 11 meters on the way up, and then it will cross that when on the way down. So you get to have a smaller time and a bigger time. That make any sense? Yeah, that's why you have two answers. So that's a big quadratic equation. Just substitute the numbers, solve it. And both of the answers are positive, so you know, it's time, both are positive. So you see the smaller time, I'm trying to draw and explain, that's time taken on the way up, and the bigger time is on the time on the way down. Yeah. All right, number 10, that's the diagram. Delta x is what you're trying to find. So that's the equation. You do not know delta x, and I called it t or delta t. Never mind. 4.9 t squared. Because v1 is 0. Isn't the initial velocity 0? So the entire first term becomes 0. This whole thing is 0 there. And you only have 1/2 times 9.8. That's why it's 4.9 t squared. That's your equation 1. And then sound comes all the way back. Displacement is velocity multiplied by time. And surely the time is the remaining time, isn't it? 3.2, take away t. Correct? So the displacement is this. You got your two equations. That's the end of physics. Now it's all math. Do what you want, solve those two, and get it. I decided to substitute for this delta x here, and that becomes another quadratic equation. Third time. Got to be really careful on this. I struggled on this because I was not getting the answer. I had missed the sign. Negative 340 became positive 340, and took me some time to realize. So you get the time as 3.1, take it and plug it back into one of those equations. I put it into equation 1, and I got it as 47 meters.